Today we're looking at models for interest formulas. Our first question has to do with doubling time, the amount of time it will take for our investment, whatever it is, to double. In our case, we know how long it will take to double, so our question is, what is the rate? Think about it this way. If you invest $1 compounded continuously, so that's the E to the RT formula, it will equal, after it's doubled, 2. No matter what you choose for your initial amount, your first step to solving this equation will be dividing by that initial amount, which will get you 2 in either case. So I'm going to substitute that time for 7.5. To cancel the E, I'm going to take the natural log of both sides and divide by 7.5. And I get a rate of 0.092 for R, or about 9.2%. For those of you that may be confused why I chose 1 for our initial amount, let's pick a different value. Let's say we invest $12 instead. We still have a doubling time of 7.5 years, and after our money has doubled, we will have $24. So to solve for a rate, our first step will be to divide both sides by 12, which will leave us with the exact same equation we started with when I chose $1. It just saved us that step of dividing. Now we're looking at our investment tripling, so we will have 3 times the amount of money that we started with. It's the continuous formula, so we have E to the R. This time we know our rate was 5.5% converted to a decimal, and our question is, how long will that take? Taking the natural log of both sides to cancel that E, and dividing both sides by 0.055. We get nearly 20 years. Finally, we will use our interest formula to find some information that we don't know. This time we do not have compounded continuously, so we are not using the PERT formula. The other formula is P times 1 plus R over N to the NT power. So we'll substitute what we know and solve for what we don't. We know we want $450,000 when we retire. So how much do we need to invest right now? That principal amount is what we'll be solving for. Our rate is 0.06125. Compounded daily would be 365 times per year, so we'll substitute that for both ends. And we would like to retire in 25 years. Again, when you put this in your calculator, use parentheses around that exponent. I'm going to start this one by punching everything into my calculator, obviously besides the P on the right-hand side of my equation. And I get about 4.623. So I will divide both sides by that value to figure out my initial investment. I will need $97,339.39 to invest if I want $450,000 in 25 years. A little bit of financial advice: the sooner you start to invest, the better off you are, because your money will earn interest upon interest. So as you can see here, not many people have $100,000 in the bank to start investing for retirement when they're 30 or 40 years old. But if you start with a couple $1,000s when you're 20 and invest a little bit each month, that will grow exponentially and be ready for you when you retire. And your U-Try question.